Hi everyone, welcome to the meeting. Sorry I had to miss it. I had a last minute family thing, so I couldn't be there in person. Um, but it's going to be a pretty quick one. I'm going to talk a little bit about the constellation Leo as part of the constellation of the month. So Leo is one of the zodiac constellations, meaning the sun passes through it during the year. It's one of the oldest recognized constellations in the human history. This constellation is probably a spring or a summertime constellation, best visible during spring evenings, especially in April and May. Uh, One of the few constellations that actually resembles that what it represents. So it at least it does make the form of an animal or an Leo, sorry, lion. This is a good mix of a bright stars, some mythology, and also some deep sky objects that we are going to talk in our next slides. So first, where is Leo? So Leo sits between Cancer and Virgo. I think if you scroll. So Leo sits between Cancer and Virgo in there. Um, it lies pretty close to the elliptical path where Sun and Moon and planets travel. Um, Also, because it's pretty close to the celestial equator, it's visible from most places on Earth. In May evenings, Leo is high in the southern horizon, southern sky, at least for us in Arkansas. So, how to find Leo? The easiest feature is the sickle. So we can just look for the reverse or a mirrored question mark symbol, and that represents the head of the lion. Uh, and also, if we follow the Big Dipper and connect, you can see the image representation. We can connect those two lines and make a imaginary straight line that should point to Leo. Also, Regulus is one of the brightest stars. So that's once you can identify the reverse question mark with Regulus, the other symbols should be pretty. I mean, the other constellations should be pretty visible at that point. Leo Minor, obviously the smaller lion. I just wanted to include this slide. This is a different constellation altogether. It's not part of Leo. It's much fainter, very and harder to recognize because there are no bright stars or no strong visual shape to it. This was added later by the astronomers to fill the gaps in the sky map. But I'm just trying to put the point here that Leo Minor is a complete different constellation, not part of Leo. Some of the key stars in Leo, one being Regulus, this one of the bright blue slash white stars about 77 light years away. In mythology, the name means a little king. And one of the fun fact is it spins extremely fast. So it completes one rotation in only about 16 hours. And because of that rapid rotation, it's slightly flattened instead of perfectly round. Um, One of the next brightest star is Denobula, and it kind of marks the lion's tail. And also we have Aljaba, which is also a double star and one of the popular double stars that we can see through telescopes. A little bit about history and mythology. Leo represents the Nemean lion from Greek mythology, and the story says, it's one of Hercules' first labors out of the 12 labors. And also the story goes, Zeus placed the lion in the sky as a constellation. So this is one of the artistical representations of Leo and Leo Minor. This is another screenshot when I was preparing the slide. I found this is something from a manuscript, pretty old, but that represents Leo and some of its stars. Leo is also considered as a seasonal marker. It's linked to the Nile flooding. So ancient Egypt depends heavily on Nile River water, and when it floods, it deposited fertile soil that is very much needed for the farming. And they just noticed that every time they observe sun during the when they observe sun in the constellation of Leo, that's when that happens. So it's kind of got linked to it. Leo constellation has nothing to do with the flooding, but it's just the way of representing from them, saying, the seasonal is being changed, or this is when they should start their cropping and things like that. I have also mentioned this is one of the zodiac constellations. So what we can see visually, some of the famous targets, Leo triplet, will talk in the next slides, but there are M95, M96, and obviously the double stars. Okay, so this is where the Leo triplet, the galaxies are. It consists of M65, 66, and NGC 3628, and it's these three are interacting galaxies. This is an image taken by Malcolm, our member, and if you are interested in the specs, I'll just pause it here for a second. But this is how he photographed this target. And I have a few notes on that. Okay, so while we are seeing this image, so Leo triplet consists of 65 M65, M66, and NGC 3628. It's about 35 million light years away. These are entire galaxies containing billions of stars in it. They are gravitationally interacting with each other, and you can see M66 shows a sign of distortion from these interactions. NGC 3628 is an edge-on galaxy. It is the image in the bottom, so you can see the dark dust structure very evident in there. Again, these are the close-up images from this slide taken by Malcolm. We have already discussed some of these. Regulus, some of the fun facts are Regulus spins really fast, and it also associated the name Regulus associated with kingship and power. Leonid's meteor shower happens every November, and it appears to radiate from the constellation of Leo. It's one of the recognizable shapes, being one of the easier beginner-friendly targets to whether to, do a visual or even photographing. As it begins the galaxy season, Leo triplet is one of the famous targets to photograph if you are into astrophotography. That's all I have. Do we have any questions? Shawn, do we have any questions?
Yep.
I don't hear
we have a new member question here. I'm gonna hand. Okay, tell it. So we have a new member here, and he's interested in you, Deepak. Tell us a little bit about or can you tell him how you got started with astrophotography?
Sure. Let me turn my video on. Okay, can you guys see me? I don't see my screen, so I can't say.
I see you.
Okay.
Yeah, we see you.
Hi. Sorry, I would have been there. I tried to attend, but today it was a personal thing. So I have a hobby of photography. I do other landscape, wildlife, whatnot, and I always had an interest in astronomy, space. That interest has been there since I was young. So I slowly started taking Milky Way and lunar images, and slowly got into DSOs. But yeah, I just like photographing this literally ancient light. So that's what makes me more
Hey,
interested
Bo.
in.
Bo, when's the best time to see Leo?
May, April or May, because it's very high in the sky towards the southern sky, right at the meridian line. So it's pretty much at overhead, and one of those easy targets that easy constellation to spot. But
Okay.
April or May is the best time to see, just because it's high up in the sky.
Excellent. Thank you, Deepak.
Sure.
Yeah. Well, that was fascinating. Yeah, and we've got some young observers here. We're going to look at Leo tonight. So that's very excellent presentation. We'll be on the lookout for Regulus and algebra. Uh, our next presenter is Michael Borrelli, and he's going to be talking about the different moons of the solar system.
Well, all right, so I decided we all know about the planets and the star clusters and everything, but most people don't talk about the moons. Yes, if you use the telescope, you can see the moons of Jupiter, the four Galilean satellites. It has more than 60 natural satellites, and you can see Titan and other satellites of Saturn. So, yes, they're not always observable, but it's something to learn about. And if you go on NASA, you can see some beautiful images of the moons that were taken by these spaceships that were sent there and the probes to see not just the planets, but their moon systems. And they're very interesting. Okay. So, just to point out, the International Astronomical Union's official name for our Earth's natural satellite is the moon, with the definite article the in front of the capitalized noun moon. And the reason we say, instead of saying natural satellites of other planets, and we say moons, because we're so used to seeing our moon and we affiliate them with being moons. And they're not, they're natural satellites, but that's the popularity of our moon. So here's some image of some of the larger moons in our solar system. What's that? Okay. Anyway, the largest moon in our solar system is Jupiter's moon, Ganymede, followed very closely by Titan, Callisto, Io, and then our moon. Our moon is number 5. And it goes all the way down. And there's some moons that are only a few kilometers. So there are 299 natural
My
satellites.
speaker's on, so they can hear you.
What's that? Who are you talking to, Perry?
It's a person out here came outside.
Okay. Any event, so you can see all this. Now, I can't talk about all 299, so I'm going to focus in on some of the more interesting moons that are being investigated. But before I do that, a very important aspect of all these moons, including ours, is something called tidal forces. Now, a tidal force is not a single force, but it's just the differential in gravity attraction by a larger body across the diameter of the object. So with the case of the Earth, it's like 6,000 miles from one end of the Earth to the other. And the moon has a differential gravity attraction, and so does the sun. And this causes a little bit of a squeezing and stretching. It's not so bad on Earth because our moon's so much smaller than we are, but it is significant for some of the moons orbiting the larger planets like Jupiter, Saturn, Uranus, and Neptune. And it actually gives them some very interesting characteristics. It allows them to have liquid oceans, for example, because a contraction like an accordion causes frictional heating. So, this is the diagram. Again, if you look it up, you can get a little confused. If anyone wants, I will send out a PDF of this presentation, and the 2 links down there show a really good illustration of how tidal forces work. Okay, better than I can show here. All right. So let's go to Ganymede. It's, as I said, the largest moon in our solar system. It's 3,270 miles in diameter. It's larger than the planet Mercury. Now, the reason it's so large is if you got the rocky mantle is smaller, all the sun's energy, solar winds, blew away all the water, ices, and heavy gases away from Mercury and the inner planets, but all out to the outer planets. So that's why it was able to capture water, other gases, and produce this larger size. If you took away all the ice, it would be smaller than Mercury. Now, it does have an iron core and a liquid iron center, so it's the only moon in our solar system that has its own magnetic field. And that's another thing that helped it hold on to its water and everything else. However, it has very little atmosphere because Jupiter kind of sucked away the gases. Again, I'm not going to go through everything here. This is just for people who want to get my presentation and read it. But it is an interesting one because it has a magnetic field. It has its own aurora. And there's an image down there showing the aurora as it was taken by the one of the spaceships and also from Hubble. So you can actually see these from Earth or from our space telescopes. All right. So again, it has a molten core that gives it from radiation decay. So that's one reason it has a liquid ocean, as well as the tidal forces from Jupiter, like an accordion squeezing it in all the friction. All right. There we go. Titan, the next largest moon. It also is larger than Mercury. It has a silicate core, basically a rocky core, just like Earth. It's a bigger rocky core than Ganymede has. You then have a very complex ice, hexagonal shaped ice, which is really almost like a metal. You then have a liquid water ocean, and the surface, it has an atmosphere. Its atmosphere is 50 times denser than Earth's atmosphere. It's mostly nitrogen and methane. It has clouds. It has methane rain. This has all been observed by the probes that were sent to Saturn. And so it is very likely that there might be an alternative form of life that lives on methane, because we have liquid methane on the surface. It could be there. And that's why they're sending a probe there soon. I'll talk about at the end all the probes that are going out to the different moons. But it also has a liquid ocean. And that ocean is salty, and information shows that it has all the organics in there that could lead to some form of life. So again, a very great interest. Now, why, of all the moons, did Titan maintain an atmosphere? Well, Titan, as you can see from the diagram down here, Titan stays, come on, pointer, it's not just showing it, there it is. Titan is within the magnetic field of Saturn. And so that protects it from the solar winds and the cosmic rays produced by the sun, so it didn't blow it away. And it's far enough from Saturn that Saturn didn't suck off all the gas. So this is one of the unique things about Titan, right? Other moons with subsurface oceans. The Jovian moons of Europa and Callisto, Saturnian moons Enceladus and Mimas, the Uranian moons Ariel and Miranda. So evidence indicates that tidal flexing keeps and also some radioactive decay, keeps these oceans liquid. Otherwise, they would be, if they were away from their planet, the ocean would likely be just solid ice. The Plutonian moon, Charon, has a subsurface ocean, but it did freeze. And there is growing evidence that the dwarf planet Pluto has a subsurface ocean. So how does the ocean on Pluto remain liquid? Whoa, they don't have an answer for that one yet. Okay, Enceladus, the oddity. It's 504 kilometers in diameter. It has a relatively smooth surface because, as you can see from the picture here, the tidal forces from Saturn cause it to have that liquid core, and it causes pressure, and you get these plumes of water. The satellites, the Juno and other satellites, not Juno, the Cassini, thank you. I couldn't remember the right one. went through these and analyzed them. It's water vapor. It has organic compounds like formaldehyde. So again, it could be life under the surface. And the water falls onto the surface here, and that's what causes the smoothness. So it's relatively, you see, compared here, this is an older section of Enceladus, and these newer areas where water landed on them, it covers up the craters. Interestingly, the E-ring of Saturn is caused by this water that's being extruded from Enceladus, and it forms the ring as it orbits Saturn. Pretty cool, huh? All right. Again, here's a diagram that you can look at if you get this. But traces of nitrogen, CO2, methane, and propane and formaldehyde were also found in these ocean extrusions. So again, they are the basic forms that people believe were in the oceans of Earth that led to the formation of primitive life. Europa. Now, Europa is a very interesting one. It has a metallic core, but doesn't have much of a magnetic field. And it has a volcanic seafloor. There are volcanoes that actually put out some lava occasionally. There's evidence for that on the planet. They believe there's also that causes the heat and pushes some water from the subsurface ocean here, but they've never observed any plumes like we just saw on Enceladus. So what's going on? It's a very different kind of world. So Europa's surface is mostly water ice. A lot of ice, a lot of water. And there's some evidence that as these cracks that form on its surface, it brings the water back down into the subsurface ocean to replenish it. But it is losing water continuously to space to form the E-ring. How long this can continue on, no one knows. All right. So icy volcanic flows, water seeping surfaces, impacts by meteorites, etc. It's a very, very geologically active moon, and probably one of the most active. All right. Except for Io. Io is closer to Jupiter, and it really feels tremendous, tremendous tidal forces. And they squeeze it and so forth so that the core is molten material. And you can see these active volcanoes that are shown on the Jupiter-facing side and then the anti-Jupiter facing side. All right. There are over 2,000 known volcanoes on Io. And here you can see one of the first early pictures showing an eruption back in 2007 of the volcano. There it is. Here's the plume right there. And then infrared images taken from telescopes from Earth and from space telescopes, you can see all these active volcanoes from their heat. Wow. Interesting place to go. Bring some hot dogs and buns. So as I said, why is Io so actively volcanically active? It has a very eccentric orbit, and so the tidal forces are far more strenuous than on any other moon in the solar system. And that's heating things up. You can see the plumes by large Earth-based telescopes and space telescopes. Io has lakes of molten silicate lava on its surface. And these were, again, seen by Juno and other spacecraft that went there. And they could actually see in one eruption, they could see the lava flow moving. Very, very interesting. All right. So why doesn't the moon have a subsurface ocean? That would have been cool, right? There is subsurface water on the moon, quite a bit of it. They estimate 600 billion kilograms of water. But the moon formed theoretically when a large Mars-like planet or planetoid called Theia hit the Earth. It disrupted, the Earth reformed, and the stubble that resulted became the moon. At that time, Earth did not have a lot of water. And all the lighter elements, all the lighter molecules were pushed away from the inner planets by the sun's solar wind and were then settled out into the larger planets out there, which then accumulated all the ice. They believe water came to the Earth through comets and other solid ice bodies from the Kuiper Belt, etc., that came in, landed on Earth, and delivered all the water. So that's why the moon has little. Okay? So, all these are very interesting. So what are we doing about it? As I said, there's ongoing observing. We as amateurs can only see a handful of these moons, the 4 Galileans. And sometimes you can see up to 5 of Saturn's moons. You can't see Phobos and Deimos on Mars. You need about a 10-inch telescope to see a few of the moons around Uranus and Neptune. And yeah, Pluto just looks like a little dot, so you're not going to see Charon and the 3 other moons that it has.
Weren't there five of them altogether?
Five what?
Don't they? 5 moons for Pluto?
I believe there are, one of the moons they consider a moon of Charon, because it's orbiting Charon, not Pluto.
Nix, Nix, yeah.
Yeah, so in any event, the Artemis program, once again, to place humans on the moon. One of our solar system's moons. Dragonfly, there will be a rotor craft, just like they had on Mars, to fly around, because remember, the atmosphere on Titan is extremely dense, and so it can easily support a helicopter, and it will have other probes on the ground to go out and to see what is in the methane rivers, lakes, and what's in the atmosphere. And that will launch in 2028. The Europa Clipper is already launched. It launched in 2024. It'll arrive in 2030, and it will see if there is suitable conditions for life beneath its ice shell, and also get more information. It will orbit and set at least. I can't remember whether or not it has a landing probe. I don't think it does. But in any event, we'll learn a lot more about Europa. And then there is one going to the Martian moons. It's called the Martian Moons Exploration Mission, MMX. And that is a joint mission with Japan that will launch later this year. So we're, again, as amateur astronomers, we're not going to see too much of the moons, other than it's nice to watch them moving around. And if you've never seen the shadow of one of the moons moving across Saturn or Jupiter, that's pretty cool to watch. And if you look in certain magazines like Astronomy, they'll tell you when these shadow transits will take place. And the other ones, just go to the NASA websites, and you can see what the space telescopes and what these probes have taken pictures of and what they've learned about the moons. They're an important part of our solar system, and they're often ignored. So I thought I'd give them a little me time, as you will. All right, thank you.
We saw a presentation on the Night Sky Network this past week and a half ago, for the Dragonfly mission, and they were talking about the density of the atmosphere makes a helicopter 40 times easier to fly than compared to Earth, and so their helicopter is 1,500 kilograms. Yeah, and it's the size of this desk. It's got 2 rotors, top and bottom. It's like a quadcopter, but it's got rotors on the top and the bottom, and it can survive with losing any 2 rotors as long as they're not on the same arm. It'll be a nuclear powered RDB battery. There's not any other place like that in the solar system that is as easy to explore, it sounds like, as Titan. That you can build a big quadcopter and nuclear powered quadcopter and take off across the surface. All righty. Thanks, everybody. Well, that concludes our presentations for tonight.